Hello students, in our earlier video we have studied about EMC, that was equilibrium moisture content, then FMC, that was free moisture content. Okay, after that we have studied about the rate relationship, which is like when we are having a wet slab of material, then the moisture content which is to be dried is placed in our earlier videos. Today we'll study about the rate relationships and the graph plotted against the rate relationships. Okay, means what is the FMC curve, that is known as free moisture content curve. Okay, so let us see the graph of FMC. See, this is the FMC curve, or you can say that free moisture content curve. Okay, you can see the four parts of the curve, and that is, first one is your initial adjustment, second is constant rate period, third one is first falling rate period, and last one is the second falling rate period. First, initial adjustment from A to B. Second, constant rate is from B to C. First falling rate is from C to D. And the last one is up from D to E. That is your second falling rate period. Okay. In this graph, you can see that it is a graph plotted by taking the FMC on the x-axis and drying rate on the y-axis. Okay. So with this graph, what we assume? Okay, we can find out that the point A to B is initial adjustment period. Okay, and what happens in this period? That the solid which is to be dried absorbs heat, and when the temperature is getting increased, the solid is absorbing the heat, and when the solid absorbs the heat, the moisture begins to evaporate. Okay, means as the hot air is getting inside the solid material, in the same time the moisture is getting to evaporate. Okay, so after some time what happens? The temperature stabilizes, means the heating and cooling rate will be equal. So this temperature is equal to the wet bulb temperature of the drying air, and that point is being referred as point B. Okay, second is your B to C constant rate period. And what happens in this constant rate period? The temperature remains constant and the rate of drying is also constant. Okay, means the moisture that is evaporating from the surface is replaced by the water which is diffusing from the interior of the solid. That's why both the rate of drying and the temperature both are constant. The rate of diffusion is equal to the rate of evaporation, and in this the moisture content at the end of the constant rate, that is your point C. Okay, it is referred as critical moisture content. Here rate of evaporation is equals to rate of diffusion. That's why this B to C is known as constant rate period. Okay, now let us study what is happening from the point C, that is your critical point moisture content, to point D, that is second critical point. Okay, now what is happening here? The CD represents first falling rate period, or it is also known as the unsaturated surface drying. In this period, surface water is no longer replaced at a fast rate, okay, enough to maintain a continuous film on the surface, and the dry spots begin to appear, means the rate of drying begins to fall off at this stage. Okay, that's why the point D is referred as second critical point. Here rate of evaporation is greater than the rate of diffusion. Now last one is from D to E. This represents the second falling rate period. In this what happens? That the rate of drying even falls more rapidly than the first falling rate. And in this period, what is happening? Rate of drying is dependent on the rate of diffusion. So, rate of drying is directly proportional to the rate of diffusion of water vapor. Okay. That's why the point E is known as equilibrium moisture content here. Okay. So, point E is known as equilibrium moisture content. So, after that, the drying rate is equal to 0. Therefore, the temperature and moisture content remains constant. So, beyond E, the continuing drying will be waste of time and energy. Okay. After that, now let us moving towards the drying equipments, okay, or the dryers. First, how can be the dryers are classified? Then we'll study the factors that are affecting the selection of the dryers, okay. So classification of the drying equipment can be on the basis of the mechanism, okay, and the advantages and disadvantages. So the solid which is to be handled, they are classifying the drying equipment. Like we can say that there are various types of dryers. First one is your static bed dryer. In static bed dryer, what is happening? The system in which there is no relative movement among the solid particle being dried, although there may be bulk motion of the entire drying mass. This is your static bed dryer. Examples of a static bed dryer are tray dryer and freeze dryer. Okay, nothing is getting moved. Okay, what are the advantages of static bed dryer? Attrition, no attrition is present in static bed dryer because nothing is moving in this. Okay, if there is no movement, then there will be no attrition. And disadvantages, only a fraction of the solid particle is directly exposed in this static bed dryer. Second one is your moving bed dryer. Moving, in which the drying particles are partially separated so that they flow over each other. Okay. So example for moving bed dryer is drum dryer. And advantages, the entire material is continuously exposed to the heat source. So better drying will be there as compared to static bed dryer. And that's why, because it is moving, so disadvantages will be attrition is possible. Okay. Third is your fluidized bed dryer. In this, the solid particles are partially suspended in an upward moving heated gas system. This is your fluidized bed dryer. Advantages of fluidized bed dryer: solid gas contact is excellent, uniform drying will be there. Again, attrition will be the disadvantages of your FBD. Last one is the pneumatic dryer. What is happening in pneumatic dryer? The drying particles are entrained and conveyed at a high velocity gas stream. Example of pneumatic bed dryer is spray dryer. Advantages is it is having efficient and rapid drying. So this was the classification of dryers, mechanism, examples, advantages and disadvantages. Now let us see what are the various factors that affects the selection of the dryer. First and basic factor is the property of the material that is being handled. Means what can be the properties? First is the physical characteristics when dry, physical characteristic when the material is wet, corrosiveness, toxicity, flammability, particle size, abrasiveness. These are the various properties of the material which is to be dried in our equipment. Okay. Next is what? Drying characteristics of the material. Drying characteristics, what is happening when the drying process is taking place. Like what type of moisture is present in the material, means bound water, unbound water or both. Then what is the initial moisture content? Then final moisture content means after the process of drying, what will be the final moisture content in that material. Then permissible drying temperature, that will the material be able to handle the higher temperature or it needs lower temperature dryer. Okay. Last one is probable drying time for different dryers. Third point is the flow of material to and from the dryer. Okay. In flow of the material, what is the quantity to be handled per hour? Means it is a large quantity product or smaller quantity product. What kind of operation is this? That it is a batch production or continuous production. Then the process prior to drying. What are the various process which is taking place just before drying? Okay. And the last one in this is process subsequent to dry. Then what are the product qualities? Means what kind of product qualities we have to take care of. That is, first one is shrinkage. Is any shrinkage is there in your solid material? Then contamination. If the material will lead to contamination or not. Uniformity of the final moisture content. Then decomposition of the product. Rate of subdivision. Product temperature. Bulk density. These all are the product qualities. Then fifth one is the recovery problems. Means what will be the recovery problem we have to face while the drying process is carried out. First one is the dust recovery. Second is your solvent recovery. These all are the drying processes steps that we have to recover. Okay. Then sixth one is the facilities that is available at the site of installation, like space for the dryers, temperature, humidity, cleanliness of the air, available fuels, available electric power, source of the wet feed, permissible noise, vibration, dust or heat losses, exhaust gas outlets. These all are the factors which is present with the equipments. Okay. So we have to take care of these things also. This is a flow chart of the dryer classification. Okay. So we will stop here for today. In our next video, we'll continue with this flow chart and I will explain this flow chart to you, that how the dryer is being classified on the basis of this. Okay. Thank you, students.